So today we're going to do the November 2015 paper. So let's just start. The first question says find the value of 8 divided by 0.04. So this is primary school stuff. So 8 divided by 0.04. So what we are supposed to do here is to remove the decimal, like in the denominator, so that it's convenient for us. So we have two decimal places here. We have to multiply by 100 to remove the decimal, of which we have to maintain the value of this number. So that's why we multiply by 100 divided by 100. 100 divided by 100, it's simply 1. So we're not changing anything here. We just want to make this part into a whole number. So we get 800 divided by, here the comma shifts 2 places to the right, so it becomes 4. So 4 into 4 into 8, that's 2, into 0, 0, that's 200. And then you're done. Let's move to the, okay, this one was the A part. So this one was 1A. Let's move to the B part. The B part says simplify this, giving your answer as a fraction in its simplest form. Okay, so we have 1.5. This is also primary school stuff. Minus 4 by 7 plus 2 by 3. So here we change this into an improper fraction. We do that by multiplying 1 by 2. Then we get 2 plus 1, then we get 3. So this is 3 by 2 minus 4 by 7 plus 2 by 3, like this. And we have to find the common denominator. The common denominator is the lowest common multiple. For 2, 7, and 3, here they don't have any shared factors. So you just multiply all of them to get the lowest common multiple. So you get, this is 21, 21 by 2, you get 42. Okay, so 2 into 42, you get 21, 21 by 3 on this part. Minus 7 into 42, you get 6, 6 by 4 on this part. 3 into 42, you get 14, 14 by 2 on this part. Okay, so here 2 by 21, you get 63 minus 24 plus 28 divided by 42. Okay, then here on this one you get 4. So you get 63 plus here. This one you get 4. So 63 plus 4 over 42, which you get 67 over 42. This one they will accept, okay? But you can also change to a mixed fraction. So how do you do that? So you say 42 into 42, 1 into 67, you get 1. So 1 and something. So here I was trying to work out the remainder. So 7 minus 2, you get 5 here. Then 6 minus 4, you get 2. So your remainder is 25 over 42. You can just double check that there are no, you can't simplify this any further. So just double check, but 25 and 42, they don't have any common factors. So we are supposed to get 1 and 25 by 42. Then let's move on to question 2. Question 2 is about substitution, okay? So it says, given that P equal to this, Q equal to this, R equal to this, evaluate P plus Q over R. What I advise you to do here is always use brackets. Even when it seems obvious, okay? Just make it a habit to use brackets. So for example, P here, it's -4. So I put -4 in brackets. Plus Q is what? It's 3. Put 3 like this. Then divided by R, it's -1. I can even put in brackets still, that's fine. So here you get -4 plus 3. You get what? -1 by -1 here. Then you get 1. And that's it. So you get 1 on the first part. I don't know why I keep on writing B every time. But yeah, this was supposed to be 2a. So the b part is okay, let's free up some space. So 2b says square root of, that's p squared q. So p squared q minus r, like this. So again, always use brackets, just like I advised you. Okay, so p is -4, -4 squared q is 3, then minus r it's -1. Okay, here I think this one it illustrates best what I was telling you about brackets. If you don't use brackets, you might forget that there are two negatives here. Okay, so always use brackets. Here you get 16, so 16 by 3. Okay, I'll just do it in steps so that we don't lose anything. Here negative and negative, we get positive. So here we get 48 plus 1 equal to square root of 49. In paper 1, almost always, unless you are told to leave your answer in set form, what it means is you get your answer usually as a whole number. Okay, so for example here, the clue was that whatever you were supposed to get here, it must have you should be able to get the perfect square root. So it's also another way you can make sure, just check if you're on the right track. If you're getting answers like square root of 101 or something, then you just know that somehow maybe you made a mistake somewhere. So that's it for the question 2. Let's move on quickly to question 3. What does it say? Question 3 says, in an athletics competition, under 20 boys compete in a 5,000 meter race, whilst under 16 boys compete in a 3,000 meter race. Calculate the difference in the distance they run, giving the answer in standard form. Okay, so here the distance for under 20 boys, it's 5,000 meters. What is the distance for? Where is the distance for under 16 boys? It's 3,000 meters. So you get the differences, 2,000 meters. Okay, then you should change this to standard form. Standard form means the first number should be we call it a. So a should be greater than or equal to 1, but it should be less than 10. Okay, so a should be a single a number which is between 1 and 10. It can be 1, but it can't be 10. Okay, so here that's why we adjusted. We just put the comma such that our number is between 1 and 10, and then we have to readjust this such that it retains the value of the number. So this one was 2,000, so we actually shifted the comma. Let me show you real quickly what we did. So we actually shifted the comma to the left 3 times. So to correct that now, since we made this, another way to look at it is we made this number smaller. 2000 by saying 2.000, we made it smaller, so we have to readjust it. How do we do that? Our power here must be positive. Okay, so we have to power it. We have to power it positively such that we retain our value, and then this is what we get. So let's quickly move to the second part. Second part says a lap is 400 meters long. Find the number of laps in the 5,000 meter race. So number of laps would be 5,000 meters divided by, this is 400 meters per lap. Okay, I'll show you if you don't understand this way, I'll show you a very simple way to go about it. So you get 1 here, you get into 10, you get 2, then you are left with 2, and then we add a 0, then you get 5. So 12.5 what laps. So I had said I'll show you a good way to go about it if you don't understand it directly. So you have you're told that in a lap, so 1 lap, simple proportion, is to what? 400 meters. How many laps are 5,000 meters? Obviously it'd be what? Be more. If it's more, we say bigger number on top. Okay, so 5,000 meters over 400 meters times 1 lap. So you'd use simple proportion here. The meters, they would cancel, and then you'd still get 12.5 laps. Okay, so this is done. Let's quickly move to question 4. Question 4 says it is given that OP is equal to -2.7 and OQ is equal to 12, -5, where O is the origin. Express PQ as a column vector. Okay, I'm going to use the space above here. You'll know why I'm doing it later, just to save up some space, because we'll need to do several calculations here. So this one's very popular in ZIMSEC, where you're asked to find the column vector for a given vector. For example, you're given this in this notation, and then you're asked to find the column vector. You also have this position vectors. The last number, you just put O and the last letter, or in your vector. So the position vector that defines the last letter, which is Q in this case, then you say minus the position vector that defines the first letter here. So you get like this, and OQ is equal to what? 12, -5, minus OP is equal to what? -2.7. This you get 12 minus 2, which means 12 plus 2. Get what? Get 14. Then minus 7 minus 5 minus 7. You get -12. So this would be your answer. So that's it. The B part says the B part 1 says find OQ, so the magnitude of OQ. So OQ already you have. So what you do is you just write your statement as given. These bars, they only mean size or magnitude, and then OQ. So when you're told to find the, let's say, XY as a column vector, XY, magnitude of XY would be equal to square root of x squared plus y squared. And don't forget to use brackets, okay? Especially if you get the numbers confused frequently. Just to be safe, just use your brackets so that there are no complications. So OQ for this one is 12 squared plus -5 squared. Okay, if you had not used if you had not used if you had not used brackets here, maybe you would have made some mistake and on this step, because this one is supposed to come out as positive. So here you get 144 plus here you get 25. Okay, add the 2, you get 169. Square root of 169 is equal to 13. Okay, so if there are no units given, you just say 13 units, and then that's it. So this part you're done. My handwriting is very lousy. Then yeah, so this part you're done. Okay, so the reason I wrote this here is that we want to use it for the last step. Okay, so B2 says find the coordinates of M, the midpoint of P and Q. Okay, so if you want to find the coordinates, it's simply the position vector. If you convert this, for example, the coordinates for OP, they are -7, -2, 7. Okay, so you have to find the column vector for OM first. But then how do we do that? M is the midpoint, so you're getting from, let's say this is your Cartesian plane, and let's say this is P, let's say this is Q, okay? So you're getting from O here, then you're going to P. Our P is obviously different because this one is -7, and so it was supposed to be somewhere here, okay? I'm just illustrating in general. Our P and Q, they're just general points. Then from here to here, we need at this point here M. So what would it be? OM would be equal to OP. You need to get to P first, then plus this vector here up to this point. So it'd be plus what? Plus PM. Okay, from P to M. But then we know that PM is equal to what? PM is half PQ. Half PQ. Okay. So OP is equal to -7 plus half PQ. PQ is equal to what? 14 -12, like this. So that's why I say that we needed to use this, okay? So that we don't, yeah. So you get -7 plus half of this, you get 7 minus 6, okay? So -2 plus 7, get 5. 7 minus 6, you get 1. So therefore, M equals to 5, 1, okay? So OM, when you write OM, if you write OM in coordinate form, that would be your coordinates, okay? So the column vector for OM, since OM is a position vector, it means that you can convert this to coordinate form like this, and then you're done. So let's quickly move to question 5. Question 5 says express 1 by 3 to the power 5 plus 2 by 3 to the power 3 plus 3 is a number in base 3, okay? And then you're given one mark. Sometimes those marks can be a guide. If you have many marks, if you have only a single mark, sometimes the answer is obvious, or it doesn't require you to work out that much. So what most students would do is they would add this and then get the number, and then they would convert this to base 3, which is okay. You still get your marks, but then the problem is you're wasting too much time. You're supposed to recognize that this is the form that we use when we're converting a number to base 10 from base what? From base 3. So you can see that this is the what? This is the base. And so what you do is you complete it how it should have been written. So here we have this one for 3 to the power 5. We have nothing for 3 to the power 4. So 3 to the power 4, you have to replace it with 0. Okay. 3 to the power 3, we have 2 times 3 to the power 3. 3 to the power 2, we don't have. Okay. So it's 0 times 3 to the power 3. Then 3 to the power 1 we have, because this is 3. Okay. So this would be 1 by 3 to the power 1. This is simply 3 to the power 1 here. And this was a part of the trick in this question. Then plus the numbers we don't have. So this would be 0 times 3 to the power 0, like this. So this would be what in base 3? You just take these numbers, these numbers, these numbers, these numbers, these numbers, these numbers, and then that's it. You're done. So if you don't understand this is how, let's say you're given this number and then you're asked to convert it to base 3, you would have written 0, 1, 2, 3, 4, 5 going to the left, and then you'd be taking number by the base to the power, the little number that we put, plus number by, so we are going back to this. So you're supposed to, when you're dealing with maths, you're supposed to know the reverse as well. So that's what they wanted you to recognize here. And then to fill up your stack so that you have each power is represented. So here 3 to the power 4 was not represented, so you can just say 0 times 3 to the power 4. Okay, so that's it for question 5a. Let's quickly move to question 5b. Convert this to a number in base 10. So we have 101 base 10. Okay, it says convert this to a number in base 9. So you use your T diagram. So it'd be 9, whatever base you want to convert to. So 9 into 10, that's 1 remainder 1. 9 into 11, that's 1 remainder 2. 9 into 11, that's 1 remainder 2 again. 9 into 1, that's 0 remainder 1. Then you take your numbers going from top to bottom. So it'd be 122 plus 9, like this, and you're done. Okay, so whatever number base that you want to convert to, if you're converting from base 10, you just keep on dividing that number by the given number by the number base, the desired number base, and you just keep going until you get 0 here, and then you read from bottom up. Okay, then you get 122 plus 9 in our case. Let's move to question 5c. It says 203 base 7 minus 154 base 7. So how do you do this? 3 minus 4, we say that it can't. Okay, so what do we do? Let's say we had 203 minus 154. Let's say we were just doing it the ordinary way, and we were in same primary school. You would have said, you would have put here 1 to make this 13. The reason we make this 13 is that we are in base 10. Okay, then we would have made this 6. So if we're in base 10, it means we add 10 here. So the same principle we use here. We are in base 7, so we add 7 here. If we add 7, we get what? Get 10. Then here we increase by 1. Same, 0 subtract 6. It can't. So we add 7 here. Then add 1. So 10 minus 4, you get 6. 7 minus 6, you get 1. So your answer is what? 16 base 7. So just like in primary school or in ordinary math, when we say 3 minus 4, or when we say a smaller number minus bigger number, we always increment this by putting this 1 here. We do that because we're in base 10. All numbers that don't have any base, they're in base 10, so we add 10 here. So in the same sense here, we do the same thing, but then we're in base 10, so we only add 7. But then the other procedure is the same. You just increase this 1 by 1, and that's it. And we'll continue from question 6 to question 10 in the next video. Thanks for watching. Cheers.